So let's discuss how to price bonds. Now, to begin with, I want to provide you with a copy of a slide that includes journal entries for the three types of scenarios regarding pricing of bonds. This only deals with the issue transaction, and you're either going to do it or issue at face. Oops, excuse me. Issue at face, or at a discount, or at a premium. And so, in a previous part of the lesson, you probably saw that when it comes to face or issuing at face, the contract rate is is equal to the market rate. In this specific example, the given information was that the bond was $100,000, 5 years, semi-annual interest payments, and a contract rate of 12%. If we assume that the market rate was also 12%, then you're going to be issuing at face, meaning there's no premium or no discount. In the case of a discount, so I'm going to talk about this one first, the same $100,000 bond, 5 years, meaning 10 periods, which there are semi-annual interest payments, and a contract rate of still 12%. That doesn't change because remember that the terms of the bond are fixed regardless. So that's always the same. So 12% for the contract rate. Now in this case, the market rate is actually 13%. So the market rate is higher. That means that the bonds are going to provide the investor with a 4% return, but the market rate actually requires 13%. So there has to be some kind of adjustment to the price, because that's the only thing that could be manipulated to effectively provide a different return or yield to the investor. And so if you notice, the investor will only need to loan something under the face amount. And in this case, it's actually 96,406. The face amount is still the liability. So this is what it's going to be returned to the investor, even though they only loaned 96,406. That difference is referred to as the discount on bonds payable. And there's some mechanics to figure out exactly what this amount should be. So at this point, we haven't seen that yet. But just for now, trust me, that is the discount amount based on this pricing that are actually is based on the market rate of 13% to come up with that amount. The premium situation is very similar in that in that case, a contract rate is still 12%, but in that case, that is actually more than the market rate, which is at 11%. In that case, the bonds are giving too much through the interest payments, and so we have to adjust the proceeds of the pricing of the bond to effectively reduce it to 11%. And to do so, we're going to ask the investor to loan something above the face of $100,000. So in this case, will be $103,769. We're still going to return to the investor at the end of the period of the life of the bond the full face, which is actually less than the borrowing. The difference is what we refer to as a premium. So I'm gonna now turn to another example with a much more simplified scenario, but it works the very same way. Remember that these bonds that we're looking at the moment, they are 100,000 5-year semi-annual bonds. The next one, the actual example, will be a little different, you'll see. So I'll start with this. And here, Betty Inc. is the borrower or the issuer of the bond. And Ivan is the investor. And so they're going to be either having a scenario that where the face and the market rate is the same. So you're going to be issuing at face. That's this scenario. A independent and different scenario would be issuing at a discount, which will be this one, and then finally the premium. So you're going to be talking about three independent scenarios. And so the first step really is to figure out what is the difference between what the bond is providing and what the market rate is requiring. So the investor here on this side, Ivan, in the first case, is requiring the market rate of 10%. That is based basically on Ivan going out to the market and looking for similar risk profile investments. And based on that research, he figures that the investment that applies is at 10%. And so it just happens that there is a bond provided by Betty that is also 10%. So simply, Ivan will be, fine with investing his money into this bond. Now, the next scenario is a little different. The bond is still the same. I haven't said the bond. The bond in this case was going to be a face of 1,000, 10%, one period of one single year at 10%. And so the same applies for all scenarios. So the bond in the discount scenario is still the same, but in that case, the market rate for similar investments that Ivan is looking at is actually now 12%. So it is higher. So how do we make sure that we still? I mean, I'm talking about Betty now. How would we make sure that Betty can still attract Ivan, even though Ivan is requiring 12%, while the bond is only offering 10%? That's really the question here. In the premium situation, the bond is still the same, but now Ivan is looking to, or it will be satisfied, with 8%. So it's lower. And again, in that case, Betty's bond is giving too much, and so but Betty doesn't want to do it either. So then she wants to adjust the, the the pricing of the bond so that effectively Ivan will only yield what he wants or what he requires, which is 8%. Now let's talk a little bit about the cash flows that come from these situations. In this case, we're looking at in each scenario at the red flows here. That represents the cash flows that come from the bond and that Ivan will receive. And in all cases, Ivan will receive some kind of interest payment. In this case, remember there's only one payment. It's only 1 year. And also at the same time, because at the end of the life of the bond, the investor will get back the face. So they they both come at the same time because it's only 1 year. So Ivan is getting both the interest and the face amount under each of the three scenarios. The question here is, based on the different market rates, what is this amount gonna be in each case? We know that this one should be the same as face, so that's automatic. We don't have to really worry about that. But these two amounts will be the same. How much do we have to reduce the bond buy to make up for the 2% differential there, and how much do we have to increase the bond buy here to make up for the 2% here? That's the question here. So let's talk about the one for at face. So here it is. So the first step is really to figure out the cash flows, which we just did. We know that from the calculation of the interest, we're gonna be actually computing that there's $100 interest payment based on $1,000 principal, 10% the interest rate, and it's 1 year. So the return, or the first of all, the payment to at the end of the year for the interest payment to Ivan will be $100, and also another $1,000 comes to return as a return of face to Ivan. and the question is, well, based on these cash flows, uh, what should be the price for that the bond should be issued at? And so, what are the proceeds to Betty? Well, it's going to be 100,000 because, as we said before, we already know that in this case, there's no discounting and no premium because the market rate is the same as a contract rate. And just to kind of prove it, let's talk about it this way. We know that Ivan will get $100 interest payment at the end of the year, and his investment will be, I should say, because we're talking about what happens in the future. So will be $1,000 investment. So in total, he's going to be getting the 10% that he requires, and so there's no need to do any kind of adjustment to the bond. So Betty gets face the proceeds. So that's the reason we have this there. Now, how is that different with the other scenarios? Let's look at the discount. In this case, again, the interest payment is the same. That doesn't change. So the interest payment will be providing 10% to Ivan right there. But Ivan requires 12%. So we have to somehow make it up. And in this case, I'm not going to show you the mechanics of how we get to that number, but I will share with you that I already did that on my own, and the amount that we have to reduce it by is $18. So we're going to be reducing it by to $982. So this is how much Ivan will loan, and yet at the end he'll get $1,000 back in addition to the interest payments. So how does it translate to the 12%? When you take the $100 that was earned through the interest payments and the 18 that was basically earned through the discount, and you now have 118 total return divided by the total loan from the investor's perspective. That's the investment on this debt. So it is return on investment. So it's the return is at 118 over 982, and that will give you the 12%. And that's how you make up for the 2% is through the additional 2% represented by the discount. In the case of the premium, is a similar process. Again, there's a 10% return through the interest payments, but the required ROI will be 8%, and Ivan will be very happy if he gets 10, but Betty wouldn't be. So Betty has to adjust downward. In that case, Betty will ask for 1,019. So that's when I have this 1,019 right there. That's the loan itself. And so again, through the interest payments, Ivan gets $100, and this extra $19 that come from the premium goes against his return. So in reality, the net return to Ivan will be only $81. His investment amount is 1,019, so he earns the 8%, and he's happy because that's what he really needs to be satisfied, the market rate. And so and Betty will be happy too because she's able to still attract Ivan to her bonds and not overpay. Having seen all three of these scenarios, here's the summary of how we come up with those cash flows and how they are converted to interests. And so hopefully that makes sense. Now let me go back to the initial example we talked about here. So the simplified example is very much the same as this example, even though this is more complicated. It still applies. The proceeds are calculated based on those cash flows that we just talked about, and part of the calculation will be to figure out what's the present value on the interest payments from this bond. And I'll just share with you, this actually is $100,000 bond. The interest rate, the contract rate is actually 12%, but it's actually half a year payments. So really we have to apply half of the 12, it will be 6%. So the payments themselves is $6,000. I'll show you this because in the next slide we'll see where that comes in. And so given that in the case of the premium in this situation, the contract rate, as we said before, is actually 12%, and the actually the other way around, the market rate is only 11%. We have to figure out how much we have to reduce that by, and we already know it's actually this amount, but I'll show you how we came up with it. Um, the similar situation for discount is, contract rate 12%. In this case, that's less than the market rate of 13%. So we have to somehow make up for that differential, and that again, that would be this. And I'll show you that one. Now, I won't show you the premium one. That will be in a different Excel spreadsheet, but the same price applies to discount, obviously. So I'm going to show you this one here in the next slide. And here it is that's the amount there. Now that we know that, and we know that the face will be, or the payable, the liability will be 100,000, here's the discount. I hope that was helpful. Enjoy. And this is what happens here. So notice that I've got listed all of the periods, and I said there were actually 5 years, semi-annual, so that means there are 10 periods total. Then I line up all of the interest payments. There will be one every 6 months, so there'll be 10 of these interest payments. And then at the end of the life, there will also be a secondary cash flow for the face. And so it is one way to do this. There's many different ways of coming up with the same answer. So notice in my case, I just simply took the overall 106 here for period 10, applied the present value factor of one single amount factor, and then I came up with that present value for this amount. Now this is the present value as of here. So basically, you're doing this amount and bringing it to the present. Same thing with this one, 9. You have $600. Here's the present value factor of 1 of a single amount, and so that translates to 34.90, 3404. So again, this basically comes here. And so you do the same thing with all of these. And so you sum them up, and you make that sum, that comes up to this amount, 96.46. Since you're using the market rate to actually do the present value, the number will end up being different than the initial phase. And we can talk about the mechanics like that in a different discussion thread probably. But that's how we came up with the 96.406. And so if we